Hey guys, welcome back. I think we're going to jump into another problem. Yesterday's hard problem took a little while, but yeah, I want to dedicate a little bit more time than just the interview. I want to look stuff up so I can actually learn. And then, yeah, the LLM also helps. As we saw yesterday, it doesn't get the correctness part, but I think it's still useful for analyzing the problem and suggesting possible improvements or feedback in a way that looking at the raw solutions on LeetCode don't really do. All right, so let's just jump into the next problem. Let's do number 12, integer to Roman. Oh, okay. So Roman, like the Roman number system. So I is a 1, V is 5. What is the actual question? Given an integer, convert to Roman numeral. Okay. And there's only one tricky thing about Roman numerals. It's that the values don't go exactly from left to right in terms of increasing magnitude, because they have this system where you can subtract 1 or 10 by placing the smaller value to the left. And I'm actually a little fuzzy how that works. I'm familiar for IV and IX. That's 4 and 9. But so XL is 40 and XC is 50, X is 10 and C is 100. So for example, I don't think you can do IC, meaning 99. You have to do CIX. Yeah. Alright, so I'll just put some test cases here for what I expect. I think CIX is 99. And I think IC is illegal. Yeah. Let's see how they handle the illegal cases. Alright, well, they just guarantee, it doesn't say they guarantee the inputs valid, but let's see. Oh no, you're given the number, right? So you don't have to worry about those cases. Let's think about the inverse problem. Yeah, so 99 goes to CIX. Alright, so only powers of 10 can be appended consecutively. Alright, so you cannot have like VV, meaning 10, or LL. You only can have one L basically. Yeah. Okay, yeah, so it's this interesting thing around being able to repeat the thing 3 times. And yeah, here's a nice little explanation. So we're going to be converting the base 10 into this Roman format. And one question is, if we're going to do this iterating over this number in base 10, can we just look at the leading digit? So in this example, it looks like, yeah, so I know we're at the 3000 position, and I can just add 3m. If I'm at any other number, like 7 for example, I think I just convert that, or I have to remember that this is 700, and then I can just say whatever 500 is plus 200, right? Yeah. DCC. So D is 500. Great. And then 40 is represented as LX, or rather XL, because 10 less than 50. Okay, so it looks like you can do this digit by digit. You just, and the maximum number is 4,000. So this is, yeah, this shouldn't be that bad. I think we can just jump right into it. So let's iterate over the number of digits. So we actually want to go down. So the number of digits is going to be num. We want to know what power this is. And yeah, there are simple ways we can do this, like just divide by 1,000 and that'll be 0. No, that wouldn't work. Yeah, you divide by 1,000 and you check if you have a number greater than 1. But if there's a longer problem, and maybe even for this problem, you can just take a logarithm to find what power something is raised to. I don't think log, I'm not sure if log is supported here. Probably import it from the math library. And then you need base 10 log. What other ways? So power 2 is a little easier, right? You'd still have to iterate over it. I'm a little hesitant to use the logs because of potential rounding issues. I think it'd be okay, but I think it operates by default in a floating point environment. Anyway, let's do it the simple way first, and then we'll speed it up because yeah, you know, another easy way we can do this is it doesn't matter the order, so we can also start at the end, right? And then we don't have to keep track of the digits. So I can just do while remainder equals num. No. So I'm keeping track of the power of 10 that we're doing. Okay, so while num divided by 10 to the power so this is checking if the current digit is still greater than 0. What we can do, and at the end of the loop, we're just going to increment power. So what we can do here is just do the digit equals num divided by 10 to the power. Yeah. So we take the floor division, so we get rid of the floating point part. And then we do a mod 10. So this will get us the current digit. So we start at the ones digit. And then from there we just have to convert to this format here. these are the symbols we worried about. And we only have to worry about four different powers. We don't even have to worry about the 5,000 case, it looks like. Yeah. So let's do like, yeah, so one simple thing we could do is just write the map. That might be the simplest way to do this. Let me think about that for a second. Let me think about that. If we use a map, yeah, let's just do that. I think this is reasonable to do. So and in the case when you have 0, you don't have to write anything, I think. So yeah, we could do this a little different, but I think it's actually relatively simple. I don't know. Yeah, I'm not sure if this is a thing you'd want to do in the problem, but let's just go for it, and then we can look at later. Because this looks kind of stupid right now. I'm not sure. But it's funny, so I wanna first do it the map way. Yeah, so I mean, we could also like programmatically generate this. Maybe that was better. But yeah, sticking the like the IV part seems error prone. And this is so simple. Yeah, and you have to remember like IX and stuff like that. Alright. X. And then what is this? This is XL, I think. And L. No. LX. LXX. It's funny. And then this is XC. C, 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 C. What's 500? D. So that's C, D, 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 C, D, C, C. Yeah, I'm not sure what the best approach is. But again, we'll compare later. But yeah, this is kind of a funny solution, so I want to go for that. But yeah, this using a map like this is kind of can sometimes reduce the coding complexity. All right, and it's pretty easy to understand as well. Yeah, one danger here is you could like, oh, I forgot to put these in quotes. Shoots. Yeah, so this is something in Emacs. You could just write a little macro to search for the colon and go to the next line. And just repeat this a lot. not. Alright, yeah. I think it's wasting a little too much time. So maybe this isn't the best approach. As an interviewer, I'd be a little annoyed if I saw somebody spending 5 minutes just writing the map. I honestly thought it would be a little shorter, but whatever. Okay, so we have our map now. And let's call it something better than a map. Let's call it decimal to Roman digit. Alright. Results. So we want to prepend here, right? Because we're going up. So whatever old result was, plus decimal to Roman digits. And let's say that is digits times 10 to the power. Yeah? Plus result. And then we just return the result. Let's think about this. So what are some examples we can go through? Let's do this one. And this one, we start at power 0, and the num is 3,749. Result starts empty. Okay, so we multiplied 10, or sorry, we take 10 to the 0th power, which is 1, and we divide, and that's divided by, we divide number by that. Okay, so that is also 3,749. It's greater than 0, so we enter the loop. Digit, now we do the same thing, so number is still 3,749, and we mod 10, so that should give us a 9. Because mod just, in that case, it'll just give you the digit. Great. We take the result, which is going to look our map here. We're passing a 9 in, so we get IX. All right. I'm just gonna use this space. So we put IX, the add result, which is empty string. Next item. We go back to the loop. Power is now 1 because we incremented it. And so instead of 3,749, we get 374 as the result of this division. That's greater than 0, so enter the loop. Digit is going to be that 347 mod 10, so we should get a 7. And then we look at our map here. We get 7 times 10 to the 1, which is 70. So we should be adding LXX in front, right? Because next one, whatever the map gives us, plus the old result. Okay. Let's see if that matches. Oh, it looks different. Looks different. Oh, I guess it's not. Shouldn't it be LXX? Oh no, sorry. The next digit was a 4. So we would get 374, and we should be getting XL instead. Alright, so let's see, does this match XLIX? XLIX. Okay, we still match. Okay, I'm gonna say the rest works. Yeah, so that should be good. Any special cases like empty string or 0? We're guaranteed at least 1 in the number, so let's believe the contract. Let's only fulfill our contract. And yeah, I'd be willing to try this out. So we'll test on the test cases. And yes, we forgot to put the commas. All right. I would need to do solution dot. Depending on the viewer, they might think it's tacky, but I think it's okay. Just define a global here. But yeah, we could also do the class name dot this. All right, so this worked for all of the test cases. Let's submit it. Oh. And it looks like, yeah, so we didn't handle the 0 case. Because you can get 0 as a digit, right? So that was actually a good one to catch. So as a test case, we might have thought about 0. That's sort of a weakness in this problem. But yeah, you can see we do pretty well. For the low millisecond stuff, it's often noise. And yeah, there's not that many ways to do this problem that are slow, I think. So you can see it's kind of what you'd expect. Interestingly, the memory is a little higher than I'd expect, but okay. So what could we do to improve? One thing we were curious about is like, what if we programmatically handled this mapping? Would that be better? Yeah, so one thing you could do is have a placeholder for 1, 5, and 10 for the given digit, and then map that later. That might make more sense, right? So you could actually just like take 1, 5, and 10 only, or the first digit, like this, and then when you're raising to the power, you can have a power dictionary. So yeah, here's a kind of a funny solution. I just want to see how bad it looks or how good it looks. Right, first I'm going to save this solution for ChatGPT, yeah? Okay. All right. And then I'm gonna do ones to power. All right, and for this one, interested in mapping the Roman digit itself. Okay, I see, this is a little weird now. Maybe I should have kept it as 0 through 9. Yeah, this is what I'll do. I'm gonna assume there's 3 powers we need. I mean, this is the same thing, actually. Yeah, I don't want to write 10 different cases again. What I want to do is 1, should I go to you want a little dictionary here, right? That's for the 0, the 1's digit, for the 10's digit, it's X. For the, what's the next one? 100's digit is C. I don't think we need the M, but we kind of do, so we do want to handle that. So 550. This will actually kind of help me with my remembering Roman digit stuff, because I don't actually see is L, right? Or 50 is L. Yeah. And 500, is that D? Yeah. We're not for about 5,000. I don't even know if there is a 5,000. And then X is the last one. So. What is it? 100 is C, 1,000 is M. Okay, let's try that. So this is a little shorter. All right, so in this case, we don't use the power in our map. And so this is like ones in Roman. And then if we raise it to Roman digits, ones to power. Yeah, it looks like we would need to map this. Oh, this would be a great place to use a map. Right? Because one's Roman will give us a string. And then we want to map I don't think we can do the map directly on the string. We have to first convert to a list. So it's a little messy. But we can, and I'm fuzzy on how to do that. So let's just check. Well, we'll try it and check, but the thing we can do here is just like iterate over a loop and then convert that to a string. So that's going to be like for C in so you take the ones power, right? For C in yeah, I think this kind of works. I mean, it's not ideal because we have to convert it. And it's error prone. We have to really look if this is a valid solution. Ah. I guess if we're doing characters, I mean, it doesn't really matter. This is not C++, so it doesn't matter if double quotes or not. So what we get here is a key error. There's no 40 in here. Oh yeah, so remember we have to remove the power. We just want the digit. Okay, so this is totally failing. Oh yeah, and then remember that empty string maps to empty string. Decimal to Roman digits. I mean, this is definitely a little easier to parse visually, and that's really important. Okay, I mean, this part loop hasn't changed, so we're still iterating 3 times here, but we're always outputting an empty string. And the reason is that we haven't added to the result. Roman digits plus result. All right, let's try that again. Okay, so, oh yeah, converting the list to string does not work that way. So this was a weakness. Convert list to string. And I forgot, I just remembered. So what we want to do instead of string is we want like, we just want to join on empty string. So this will use the empty string as a separator. Yeah, I think this is better than a map. I still want to look up maps because this problem revealed I'm fuzzy on how to do maps. But yeah, let's submit this and see. Don't expect a large difference. Use more memory somehow. But yeah, that's not really a concern for this problem. Okay, I think it's a decent solution. You can quickly look up Python maps. I believe you pass like a lambda or something, and you do like list.map. Yeah, or lambda or a function, and then operates over every one of these, so that would have worked too. But I think this is reasonable. All right, so now let's ask chat. I mean, this is a relatively easy medium problem. Sometimes they're harder. So I think, yeah, there's not going to be a lot of feedback, but let's just see. And we've had problems in the past with Gemini not realizing the solution is correct. So we'll tell it the solution was accepted. I'll improve. Please give me feedback without concrete solutions so I can try to redo it. Okay. I mean, we could have put a doc string. Probably good to ask your interviewer if they want that or not. We also forgot to ask questions in the beginning about the ambiguous parts. I felt like the question is relatively well defined, but it might be something to explicitly say to the interviewer. Here's feedback. We use a template. Yeah, we upgrade. Areas for improvement. I didn't like this join statement. Yeah, so in some sense, our original solution it's probably easier to read. The pattern of the number and the symbol. Yeah, could we do this with one step? It does feel wasteful that we're using the Roman numerals in the intermediary, right? But I think we kind of need to do that, or it's useful to do that because of the the way you can flip, you can have subtractive digits and stuff. Okay. Yeah, I don't know if I would update based on this feedback, but let's ask us if it can yeah. Okay, so here's a superior solution with an explanation. We take the value symbol pairs and join the result. Okay, so this case they separate 4 and 9, which are subtractive ones, and then add the single digits, Roman digits. subtract. Yeah, that's interesting, huh? So the val map. So you subtract 1,000 as much as you can. You subtract 900 as much as you can. Yeah, this is a nicer solution. I like that. This would have required thinking about the problem in a pretty different way. At least for these like string problems, it's my tendency is just to go for like something that iterates linearly over the characters. But it's important to remember you don't need to do that. There are other ways to do it. So the reason the subtractive one is nice is recognizes the key insight here was that you could break it up into these atomic parts. And yeah, I did briefly think about this, but I didn't realize you could ignore like the 800, 700, 600 part. So that's cool. Let's just throw their solution in there and see what it got, just to make sure it's valid. Okay. Updated solution. Gemini solution. Okay. Yeah, so that works. It's pretty readable. And yeah, I probably like this one better. So nice job, Gemini. Let's ask it what it thinks about defining the map. What do you think about defining the map inside the function? Yes. Either class or global. And let's also I guess we want to use the word dictionary here. All right. Yeah, so if this was C, I guess you wouldn't have to worry about that. The compiler probably would not recreate the thing every time, but in Python it probably would. So yeah, you can do it this way too, or as a global. Option 2, that's the class one. Okay, and they like the class one because it's scoped a little bit. All right, good, I think we're done. Thanks for watching.